A bubble doesn't choose to be round, physics forces it. When you blow a bubble, something invisible takes over. The moment air meets soapy water, geometry wins. But here's what most people miss. The bubble doesn't know it's beautiful. It's simply obeying one of nature's oldest laws, the same law that shapes planets, droplets, and the very fabric of how energy moves through space. Let's start with what a bubble actually is. It's not a solid. It's not a liquid. It's a thin membrane of soapy water, usually between 0.0001 and 0.001 inches thick, trapping air inside. That membrane is the stage where physics performs its most elegant trick. The soap matters. Regular water alone can't hold a bubble for long. But soap molecules with one end that loves water and one end that hates it creates a barrier. Those molecules line up at the air-water boundary like tiny shields, holding the membrane together long enough for you to see what you've made. Now the sphere, why not a cube? Why not an egg shape? Because a sphere is the most efficient container. It has the smallest possible surface area for any given volume of air inside. Less surface area means fewer soap molecules needed, less energy required. Nature doesn't do waste. This principle, minimizing surface area, is called surface tension. It's the reason water beads on a car hood. It's why insects can walk on ponds. And it's why your bubble, the moment it forms, surrenders to the sphere. The shape chooses itself. But here's where the story gets darker. That perfect sphere you admire is fragile by design. The membrane is so thin that even a single dust particle, a stray hair, or a breath of dry air can rupture it. The bubble is beautiful precisely because it's temporary. Why does it pop so easily? Imagine the membrane as a stretched rubber band. The air inside pushes outward. The air outside pushes inward. They balance perfectly. But introduce a tiny hole, just one puncture in that impossibly thin film, and the pressure differential wins. Air rushes out. The bubble collapses in milliseconds. The membrane has another enemy, evaporation. Water doesn't want to stay suspended in air. It wants to return to the vapor. Over time, minutes, sometimes hours depending on humidity, the soap film dries out. It thins, it weakens. Even without a puncture, the bubble is slowly dying from the inside. Around the early 20th century, physicists began studying bubbles seriously. They weren't playing. They were trying to understand something fundamental about how nature minimizes energy. Bubbles became a laboratory. A simple toy revealed laws that apply to galaxies. What they discovered was this: bubbles follow the same mathematics that governs foam, crystal formation, and even the structure of soap films with multiple chambers. Each wall between chambers is a perfect minimal surface, a shape that bends in exactly the way required to balance all forces. It's not magic, it's optimization. But here's what those early researchers didn't yet understand. The same forces that make bubbles round also make them vulnerable. The thinness that creates the sphere also ensures its mortality. A bubble is an exquisite compromise between two opposing truths. The colors you see on a bubble's surface aren't paint. They are interference patterns. Light bounces off the outer and inner walls of the soap film. Some wavelengths amplify, others cancel out. The thinner the film, the more the colors shift. Watch a bubble age and you're watching its membrane thin in real time. Just before a bubble pops, you'll often see a dark spot appear on its surface. That's not damage yet, that's the warning. The film has thinned to nearly a single layer of soap molecules. The end is coming, and it comes fast. When the rupture happens, it's violent. The elastic energy stored in the stretched membrane releases instantly. The bubble doesn't deflate gradually, it explodes. The entire structure, that perfect sphere, disintegrates in a fraction of a second. All that geometry, all that balance undone. What remains are tiny droplets of soapy water suspended briefly in air before they fall. The bubble is gone, but the physics that created it, that remains unchanged. The next bubble you blow will follow the exact same laws. The same geometry, the same inevitable end. So when you watch a child chase bubbles, you're witnessing something profound. They're chasing perfection, temporary, delicate, mathematically inevitable perfection. The bubble doesn't choose its shape. It doesn't choose to pop. It simply obeys the invisible architecture of the universe. The next time you blow a bubble, pause, look at it. Notice how it catches the light. Notice how it trembles in the air. You're looking at a structure held together by forces so precise that they shape galaxies. And you're looking at something that might vanish in the next breath. That's the secret life of bubbles. Not a trick, not magic, Just physics, elegant and ruthless, playing out in an object so simple you've probably never really looked at it. Until now. Subscribe so you don't miss the next time ordinary things reveal extraordinary physics.